Good morning, good evening. Welcome everyone to another great session. So today we've got Leo coming all the way from, well, my other side of the world to come and present today. So thank you for coming to present about Make Your Automations More Sustainable, Leo. Leo's actually presented and did sessions with us before on API management and function apps and stuff, I believe, as well. So it's great to have you back.
Thank you for having me.
So just a bit of housekeeping for those who have joined before, like essentially it's the same blurb. This is delivered as part of the Azure Cloud Commanders Skilling Room. So within the tech community, you can go to the Skilling Hubs, the Skilling Room directory, and there you'll find Azure Cloud Commanders along with multiple other Skilling Room groups as well. So make sure you join in the discussions and then check out events like this. This is an inclusive session, so just be welcoming, respectful. Uh, Feel free to ask any questions. Like I'll be monitoring the chat throughout. We can surely we can interrupt Leo during his presentation for any burning questions to make sure they get answered. If not, I'm sure Leo will share his social media with you all, so you can reach out afterwards if you have any questions. But over to you, Leo. So thank you again for coming to present. And I will remove the screen and take
Yeah,
it away.
thank you very much. I will start sharing my screen. Okay, and if you can set it. Yes,
Yep.
great. Welcome, everyone. I hope you will have a good day, morning, afternoon, evening, or wherever you are. For me, it's already, um, yeah, quite evening from the Netherlands here. And I'm going to talk to you a little bit about how to make your automations more sustainable. So I'm Leo Visser. Like I said, I'm from the Netherlands and I'm a consultant for cloud and AI and automation and so on. I work for OGD, which will soon become the Build Beyond Technology Group. And if you have any questions now, later, or whatever, feel free to put them in the chat or later in the comments or connect with me on LinkedIn and I will also try to answer them for you. You can find the QR code here on screen. You can actually see my cursor. And let's go do it. Um, Sorry, that was a slide from a previous event. We are going to talk about sustainability today. And we're going to talk different topics. So we're going to start with what actually is sustainability. Then we're going to talk a little bit about shared infrastructure. Then we're going to talk about how to improve your code. We're going to look at some data sources. We're going to look at Azure Automation and how we can implement this in Azure Automation. And I'm going to talk a little bit about future goals. And we'll try to keep this all within the time. So fingers crossed here. And let's get on with it. Because sustainability, it's a word which is used a lot and in a lot of different contexts. And if you follow the URL here on screen for the United Nations, you will get to these global goals for sustainability development. And when we talk about sustainability, often we think mostly about the emissions, the waste, and so on, but it is a lot more. It tackles stuff like no poverty, stuff like better education, gender equality, but also the emissions, the climate, making sure that the water is nice, and so on. So, sustainability means more than just your carbon emissions. But as IT people, there's only so much we can do. So, we might not be able to hit all of these goals or do improvements for all of these goals. But there's still many areas we can improve on, and it's still a long journey. And I would always try to ask you to look for opportunities, look for places we as IT people, we as managers or whatever can improve on these goals and make sure we do stuff to reach these goals. So this talk is also only a small drop in the bucket, but it is one of the opportunities I spotted and started looking into. There are other things you can do to maybe reach the goal sooner, but in the end, we all need to figure out the things we can do. And in this talk, I want to show you one of the things I found which I think we can do. Because the climate is impacted by all these emissions and by the other things, and IT is really a significant factor in this. And we often have the problems that it's hard to sell to corporates to be more sustainable. I don't know if any of you has ever talked with corporate managers, C-suite people or whatever, and tried to convince them to take certain actions purely because it would reduce the amount of waste, reduce the amount of energy used, or whatever. If you have and was successful in it, please let me know in the chat or in the comments later on. I would love to hear your stories or send them to me on LinkedIn. And if you were not successful, please also share them. I would also love to hear them, and maybe we can brainstorm together on how to bring it in a different way to do make it possible to get it through corporate. One of the things which will light a fire on the corporate is the Corporate Sustainability Reporting Directive, the CSRD. This is a rule from the European Union. So for people in New Zealand, it might be less important, but especially for European countries and companies working with European countries, it becomes more and more important to report on your sustainability goals and the sustainability emissions and so on you are doing. And this directive has been there for a while and slowly is rolling out to more and more types of companies. So you can use this maybe to convince corporate to do something about it. Also, carbon offsets is a thing. You might know about it, you might not. If you've recently flown somewhere, you might have seen that you could tick a box to pay a little bit extra to have, for example, the carbon emissions be compensated for your flight. This is done by systems where, for example, a flight company buys what they call carbon offsets for a project where they, for example, bought pieces of ground with trees on them. And because this organization bought these trees, the trees won't be cut down and they will absorb a lot more carbon from the sky instead of being cut down and burned. So this could then be seen as a carbon negative action, which can then be sold to other companies to, in the books, make sure that it looks like they are less carbon intensive than they actually are. This is a market, so rising demand means that there's more people looking into these things, trying to make them cheaper, looking for projects, and not all these projects have always been so successfully or so transparent. So these carbon offsets, they are a bit tricky at times. Now let's go a little bit more into the technical stuff, because this is why you're here, right? You're all a little bit more technical people, I think. So let's look a little bit about at shared infrastructure. And why do I say shared infrastructure? Because with shared infrastructure, I think we can win a lot already. If you look at researchers like the paper quoted or listed here, the power use a CPU has with the percentage of utilization is not really linear from 0 to 100. So here you see a graph, and I can show it here. On the left, we see the amount of watts the CPU is using. On the right, this is the percentage. And here it shows over time the different CPU utilizations. So here we see in the red that we are almost 100% utilization. And then from here it goes down and down and down. And the blue one goes also down, but less strong. So by the time that we are at almost 0% utilization, we are still at like over 250 watts of power use, while at the peak it was less than 450. So over the span of going from 100% utilization to zero, we've only lost less than 50% of our power usage. This means that having machines running idle is very wasteful. And you can see this more in the graph over here, where you see the red line showing the energy efficiency and the green line showing the actual power. And you see that the energy efficiency becomes higher the more utilization we have, because then we're using this machine better. And a lot of machines are running in this 15 to 50% of utilization. I mean, I'm also managing some Azure environments where we have scalable machine sets or just VMs for things. And if I need to size a VM for a specific task, I will make sure that this VM will be able to do this task on the highest peak there is available. So most of the time, this machine will be running at 15 or 50%. And with scaling systems, if we scale based on the CPU percentage, you won't wait until all your machines are running on like 90%. Now you will probably start scaling up already when they are, for example, on average on 70% or so, which means that these machines are running in a way less energy efficient state than they could be. And this is why I would argue a lot for using more shared infrastructure, where instead of running your workloads on machines you host yourself and you have to manage yourself, run them on systems provided by these hyperscalers. Say, for example, you are using deployment pipelines in Azure DevOps or in GitHub, and you need to have runners working. You can use the machines provided by Microsoft and GitHub to run this on instead of your own machines. These machines from Microsoft and GitHub, they are running all the time. They are performing multiple jobs at the same time to run a lot more in this higher utilization percentage. While if you have your own machine, unless you're a very, very big software company doing a lot of deployments or using it for other stuff, you will probably not reach this 80, 90, 100% utilization. So less servers doing more is better. Now, there is more than just CPU utilization. There's also, for example, storage. And storage can be a bit of a tricky thing if you're looking at the fact of energy utilization. Because storage, especially with the newer NVMe drives and SSDs, it will go a lot more in bursts, where if you're doing reading and writing, it will use some energy, and besides that will be very, very low. But there's also tasks like garbage collection going on. If you're using an SSD, once in a while this SSD will go through the data, make sure sectors which are not used are filled up, kind of like we used to do with defragmentation on your hard disk. These SSDs are doing this for you. You don't really have any control over when it's happening. So do know that these disks will use more energy than just only running idle. Even if you're only storing data on it, you're not really using. If you want to store data in a way that you're not using energy, tape is kind of a way. Tape drives, stuff like this. still there is also energy in the form of where you have to store it in a climate controlled room and so on. But this is also, again, looking how far do you go in energy emissions. And network is always a tricky one, because if we talk about network usage, logically you would think that using more network, using more bandwidth on the network, kind of means that you use more energy. But from research, which is being linked here also, it looks like these network switches and routers and so on, they kind of always run at almost 100%. These systems are built in a way that they are running at 100%. And if you send more data through it, they don't really need any more utilization. They don't need more energy to do this switching. They're kind of always doing things already anyways. So network kind of follows like a stepped pattern where for a long time you can send more data over the line without any problems. And then at one point you reach the limit, the bandwidth limit of your network. And then you have to expand the network to make sure you can do this transferring again. And by expanding it, you will add more machines to it. You will add more energy usage to it. So this not only works locally, this also works over the internet and so on. Sending data from Europe to New Zealand should not cause any more energy usage per se, and adding more data to this should not cause it unless we're really going over the bandwidth limits there are and new hardware has to be added. So this was a little bit about the shared code. Now let's go into improving our code. Oh, sorry, shared infrastructure. And now let's go into improving our code. I believe if I now click here, yes, we can see my VS Code instance. And normally I would do this with a nice show of hands or having people in the audience ask about it. So if you want to play along, I will say when you can pause the video for a moment, then see if you can spot the problem, and if you found it, you can continue again. So here I've got a loop. This is done in PowerShell. Sorry, I'm not a real developer. I mostly use PowerShell. We've got some numbers. We've got a target number. We see if it's been found or not. We loop through all the numbers. And once it's found, we set the found on true. And if it's found, we say it was found. And if not, it was not found. Very simple piece of code. Can you spot a way to optimize this code? And if you want to find it, you can pause the video now. And I'm now going to continue to the fixed loop. What I've done is we still got these numbers and this target, and I still loop through every number. But once I find it, I'm just going to return from the loop. So I'm going to break out of the loop. So I write, we found it, and I return, done with it. If I don't find it in the whole loop, then I'm going to write, I haven't found it. Of course, there's a way to optimize this even more with better searching algorithms and so on. But overall, this will save you some energy. And what I've done is I've also run a trace where I use PowerShell Profiler, where you can run the scripts and then say what the execution time was. And the execution time is not like a perfect metric for CPU cycles used and so on, but it does give an indication. In general, something which will run faster will also run more efficient if it's not dependent on like other systems. So here we can see that the first loop and the second of the first version and the fixed version was almost like 4 times, 5 times as quick, because it doesn't have to go through all the numbers. And also due to not having to store variables and compare it again, it's even faster. Now with PowerShell, especially with these small scripts, these numbers are not very reliable, but the bigger the scripts become and so on, the better it is. And there's also ways with Profiler to see what's actually called and being able to figure this out. Another way to improve your code is to look at API calls. I love this site. I don't know who made it, but you've got jasonplaceholder.typicode.com. This is just a very simple API which presents some stuff. It's very, very basic, but it's nice for these kinds of testing purposes. And I'm going to query a specific user and just say, give me the ID. And I want to have it from user 1 to 5. And then I'm going to give back their information. Now, do you spot the improvement again? If so, or if you don't see it, pause the video now, and then we continue. So here I've got an improved version, and you see it's almost the same. The only thing I did is I took the API call out of the loop, and I just said, give me back the top 5. In this case, it's hard-coded from the top 5 here, but you can see how you could do this with code. And in this way, I'm only doing an API call once, where I retrieve these users, and then I loop through the responses and show them. Because even though adding network traffic doesn't create more energy use per se, the network stack on your computer is a lot of CPU cycles, and transforming this into a package which goes onto the network and stuff like this will add up. So this is something you do want to keep in mind, where just doing an API call will be sometimes hard for the machine. And we can see it here, where the first one did like 5 API calls and the second one did only 1 API call. Not like a 5-time increase, because there's a little bit more memory and so on, but it's a significant increase in processing time and probably also in the CPU cycles being used. The last one is almost the same as the previous one, but what I've got here is I'm just gonna call random IDs. It's not like nicely done 1 to 5. I've got some of the other ones. It might be an even more bigger one. So again, can you see a way you could improve this? If you don't, please pause the video and look for it, and then we'll continue. So what I've done here is I've added a cache. So I've created a caching system, a caching object. And every time we look for the ID, we first see if it's in the cache. And if it's in the cache, we just say that the response is from the cache. And if it's not in the cache, then we will call the API and store it in the cache. So this way, even though I'm calling, for example, number 1, 1, 2, 3 times, I'm only doing the API call once. And the same for number 2 and number 3 and number 4 and number 5. So this way I can reduce the number of API calls, store it in memory, and also save cycles being done. And here we can see this, where the first one took 400 something calls and the second one only 270. There's still a bit overhead compared to the one we had before, where we just did 5 calls, because we do have this caching system and so on. And again, with these small scripts, there is quite some variability. So to recap a little bit, CPU cycles spend energy, so limit them. This means you can also run more on the same system. If you can reduce your overall code to use less energy, you can run more of these codes on this system, especially if you're using stuff like containerization. You can just host multiple containers on the same machine. So check your loops and end them when they're done. I've seen so often that people are doing loops through email, boxes or other AD users or something, or Entra ID users. They're looping through it, they're checking stuff. And even if they know they're done with the checks, they still will continue the whole loop. Use batching where possible. Call these APIs where you retrieve the information together, or use like a batch API call where you do multiple calls in one request. It will process it on the server and send you back the responses. Be careful with your API calls. Use caching and use tools like Profiler. Almost every programming language and programming environment has stuff like profilers in them to see what's happening and to improve your code. So use these systems. Now let's go to the fun stuff. Data sources. So there's many different data sources we can look at when we are looking at these kinds of systems. And I've got a list of a couple of them here, and I'll go quickly through them together with you. So let's start with the Carbondi, Carbon Data Intelligence. This is a website you can go to, and you can go, for example, company emissions, look for example, our favorite company, Microsoft. Search, and you see that there are some disclosures from Microsoft. So this is a site where people can disclose this information themselves. The companies then can disclose it, and it's all gathered here. So if you want to know how much energy certain companies are using and they have public disclosures, it's probably on here. So it's a nice way to look at stuff. A site probably many of you know, Electricity Maps. If you're using systems like Home Assistant at home or other kinds of fancy thermostats or whatever, it will probably also try to use information from this to determine things like energy usage. It's a nice platform. It shows a lot of information. There's a very nice API. You can go to the map yourself if you want. So you can go to the map, look at the energy usage in different maps. One problem I have with it is there's not so much transparency. There is not really that much information about how the energy is exactly determined, and it's not open source, so it's sometimes harder to really validate it. Still a very good resource, and especially for hobby projects, it's very nice, but the price can be a bit high if it's for a small project. If you want to compare different cloud platforms together and see how the energy usage is in these cloud platforms, and you don't want to use the built-in sustainability dashboards they provide, because either you just don't trust the provider themselves to give the right information, or you want to see more how this data is being calculated, Cloud Carbon Emission or Cloud Carbon Footprint used to be a very nice tool. It still is. Problem is, it's quite hard to set up, and it's an open source project which at the moment is abandoned. So no new development is going on. I do still really recommend looking at the docs, because there's a lot of information about the methodology being used, which is still very helpful. A new project which is not that commonly known yet is Spruce, and Spruce is kind of a spiritual predecessor, right? At least it came after the Cloud Carbon Footprint. This is more based on pipelines, and it can create pipelines to create reports of your energy usage. It also uses your cloud usage data, uses the same kind of methodology as Cloud Carbon Footprint. In some cases, it's expanded or improved upon, and it will show you a report. It used to only work with AWS. I believe recently they've also added Azure to it, and they're working on creating feature parity between Azure and AWS. So also, if you want to compare AWS with Azure, this is really something to keep an eye out on. And this is also using the Boavista API, which is one I never heard about before, but is also very nice and is an API which you can use a lot to find out energy usage for different kind of systems. There's a whole lot about the methodology and the data repositories and the calculation engine in here. If you are an open source developer, Spruce and Boavista are both open source. I believe they can use a lot of help. There's a lot of nice GitHub issues which are good first issues. So if you want to start doing stuff in this, check them out. What we will be using today mostly is the ENSOA API. Now this API is only available in Europe. So sorry for the people watching outside of Europe, but I believe same kind of systems are also available for your regions. This is the kind of system where all the energy suppliers have to report their energy usage, and based on this, an API is set up. Electricity map is also using this information. If we look at the electricity map we had before, and we look at the regions they're showing, we see here some different regions in Sweden. They are the same kind of regions because this is using different grids which have different energy systems connected, and in these grids the energy is being sold separately. There is communication between the grids and so on. And I'm Dutch, so I like to look at the Dutch data, and especially because lately the Dutch data has not been so well predicted. So what we can do, for example, is we can check for the generation, and we can do the actual generation output per unit, for example. Let's do this one. So here, for example, we checked for the forecast for wind and solar. And it shows what we expected, and it shows what actually was done. And we can also go even a day further ahead. And then we only have like the day ahead, because there's only like a prediction, because there's no actual data yet. So for tomorrow, they expect with wind and solar to generate quite some energy. We could do this the same with other kinds of energy. And this is already a lot better, by the way, in UI as the previous version. And it takes a time to understand all these different options, but there's a lot of information in here if you dive into it. So, like I said, the ENSOA, there's this nice dashboard. There's also an API available, and there's Postman libraries available. Now, this API and the Postman libraries actually explain it quite well. They're not the most user-friendly. They use stuff like EYC area codes. So if, for example, here I would go to the generation and the generation forecast day ahead for wind and solar, we would see that we need to give the in domain, which gives here an example. And this is the EIC code. Now I know this is Belgium, and you can look this up in here. So if I would look here for display name BE and see if it would actually search. Let's refresh the page for a moment. Yeah. And I think we actually have to go to the next page, or this page is really not generated that much for searching. Let's see if NL works better. Normally it would show it now, but There's a lot of different kinds of area codes. I was on the part X, I need to be on all codes. So if we now look for NL, we see that here is like the code for NL, but there's also different kinds of codes you can find. This is something you have to get used to for a bit. I will show you later in the code how I tackled this. And if you've done this, then you can use the API to call this. There's like a period start, a period end, processing type, document type. These are different for every call you do. And this is all documented also in the docs for NSOA. It is all documented. You can look it up. It's just not the most user-friendly. So be warned. Getting the API key, on the other hand, it feels a bit weird, but it actually works quite well because it's quite simple. You send an email to the email address with a specific subject line and the email address in the body, and eventually you just get the API key. That's it. There's no real vetting going on as far as I can see. And the API key is mostly just to make sure that they can kind of see what you're doing. There is some throttling, but I've not reached the throttling limits or whatever. And I've done some quite big calls already, which we will see in a moment. Okay. Now let's go into how we can actually use this. I see the time is going real fast. So I've created two systems we can use to see how to use this. Let's go to the first one. So I've created this resource group with some stuff in it. And I've created an Azure Automation account in where I can create a runbook, a PowerShell runbook. And what I've done here is I've done the schedule runbook. And we can quickly look at this. Let's see if I can zoom in a little bit more. There's some information about the things. There is a function to calculate distance. Here I've given the different area codes. And for every area code, I've set the center of this area code. So you could kind of see this, this area, which we have here. You could see this as a polygon, and based on the polygon, decide what's the center of the polygon. And in theory, if you have a point somewhere on the map, it should always be closest to the center of this polygon where it's in, based on some math and so on. It's not 100% reliable if you're almost on the edge, but in most cases it is, and especially if we want to talk about data centers, it should most of the time be. This information used to be available. This kind of map used to be also on OpenStreetMaps, where you could get this information out of. I am still looking into a way of finding this information again and providing a better way of doing it. And I've got some of the PSR types. They're not, they're documented in the documentation. I get some variables. We connect to Azure. We get the Azure locations. So I ask for different Azure locations, because what I want to do with this runbook is I want to see when is the most green, when is the best green/fossil energy, what's the name called again, balance available. And on this time, I want to schedule certain automations. So I'm here looking for my specific region. I'm getting the EYC code for this region. And then I'm going to ask for the next 24 hours of data. I'm going to get the wind forecast and the total forecast. Based on this, I'm going to create with some math the different steps in it. Then I'm going to look for the best solution, print this, and then I'm going to schedule the runbooks. Very quickly going through the code. Let's look at the output of some. And it will show me a table like this. So we have the total expected energy. So what they expect the energy, what they expect for amounts of energy to be used, how much solar energy, how much wind energy, offshore and onshore will be available, the total. So this is just these three combined, and then also the total fossil expected. And what I'm looking here for is the place where there's the least fossil energy being used, because then no, if I'm running my code, then I know that not so much fossil energy will be used, and there's also more green energy. So I get this graph for the whole 24 hours, and it says the best slot is at slot 42, which is somewhere over here. And it will schedule my run book, therefore, at this specific time, tomorrow or today. So this is how my first idea works. The second one is moving a resource based on this information. So if I go back to my planner, what I can also do is the move run book. And we'll see a lot of similar code in here in the start. I'm connecting again. Now I get all the different Azure locations. And what I'm going to do is I'm going to check, like, hey, I want to run a specific job soon. Where can I move my virtual machine to in a way that it's best for the environment? It will call the API for the different regions, and then eventually it will give me an answer. If we look at a run which has been performed, we can see that here it shows the different regions. And then it says how much green energy will be available, how much fossil energy will be available. And based on this, I can decide to which region to move to. Now, as you see, Norway East is a very good region. Norway has a lot of like hydroelectricity and so on. So this way, it's a nice region to move to. So it says move to Norway East, and I started in Sweden Central. So these are two scripts I created you can use. I believe these are also on my GitHub, so you can look them up. If you look at my GitHub other sysops and you search for sustainability, you should find them. And let's go back here. So by using this Azure automation, you can try to reduce your emissions with different ways. Now, these things I showed you, these ideas, they don't work with very small scripts. If you have a script which is only doing a very small thing, then using this schedule script to always move it to the best scheduled time or whatever, it's probably not worth it, because the overhead cost for it will be more. But especially if you're using ETL pipelines or very heavy batch jobs which need to be done, or say like migration scripts or whatever, then using something like this might be interesting to get a better idea and reduce your emissions. Also, you can also add cost to it. There is the cost API for Azure. So you could say, for example, that you use cost as a tiebreaker or as a threshold, and only take regions into account which are near to or lower than the region you are in now. So this way you can also tell corporate, like, hey, I've kind of improved the sustainability, and maybe it's even also cheaper, or at least it's not more expensive. Because cost is also variable, and not so much on time at the moment, but especially on regions. Doing something in one region or another region can be very different in the cost. So I've got some future goals because I would like to create like a PowerShell module for ENSO-A to make it a bit more user-friendly, still working on this stuff. And if there's people who want to help me with this or want to do this, please let me know. And I want to convince Microsoft also to publish more PUE data. This is the power usage efficiency. And also the WUE, the water usage efficiency. Because I can now see for a different region where this data center is in, how the grid energy is being used. And I use this instead of the reported energy by Microsoft or AWS or whatever, because this is the real amount of emissions which are being used, instead of they said, well, we've bought 100% of solar energy, but at night when these data centers are running, this solar energy will not be available. So these grid suppliers only provide, say, we will make sure that so much energy is provided at a certain time, not specifically when Microsoft is using it. And with these PUE and WE values, we can get an even better estimate, because we can also see how much of the energy is really being used by the machines. And the newer the data center is, often, the better these values are. I also want to know more about the underlying hardware. I'm also going to look more into the Boavista API, because I think there's a lot of information in there. And I want to look more into seeing if we can maybe do something with load balancers. Instead of moving my workload to a different region, I just have a load balancer, and every now and then it checks which region is the best at the moment and moves it to this region. Especially with stronger workloads, I can then turn off the CPU or the compute in these other regions and only have to pay for the storage and only have to think about the storage. Especially if I want it to be high available anyways already, this could maybe help me. With that being said, I hope this has inspired you a little bit, give you some inspiration of doing it, and I hope you will also start spotting more ways to make stuff more sustainable. Thank you very much, and if there's any questions, you can ask them now or later in the chat or on LinkedIn or whatever.
That was great. Thanks, Leo. You reminded there's no questions at the moment, but you reminded me a lot about cloud sustainability book that I reviewed last year or something like that. And a lot of it was actually very much just lean programming, like shift left as much as possible, use as little as possible, right size. Like it's all about actually good lean architecture principles as well. So one of the things like for sustainability is just use the best thing at the right time, but also don't over engineer a product. So you don't go out of your way, like in order to implement some of these architecture patterns. Actually, you kind of best practice if you're following them anyway. It was quite insightful.
Yeah, it's always interesting if you're following FinOps in a strong way. You're often also doing a lot for sustainability already, because FinOps and sustainability often both have the goal of just reducing as much as possible, especially in a world where we pay for everything we use.
Yeah, I know Microsoft have come a long way in terms of like the carbon emissions workbook and things like that, but I do agree that there is some data that is just harder to get access to without fully fledged products and integration as well.
It's getting better and better, and especially if we keep pushing for it and also keep building our own tools around it, then they also see it useful.
Yeah, I know for me, I've definitely, I found your GitHub repo. I've also posted a link in the chat as well, but I'm going to search for those runbooks because it'll be really interesting to see the New Zealand versus Australia comparison here. I'm sure you guys will have your own little semi-wars between countries where it's just like one country will do something better than another, and
we all know Scandinavia wins anyways.
Yeah.
because they have
But
so much hydroelectricity and so on going on. So it's often one of the Scandinavian countries winning.
I suspect New Zealand might be well placed, but actually it would be really interesting to see. So I'm going to take that away.
Great.
But there's nothing else in the chat. So I did have some sort of takeaway considerations for people that have watched this, as well as like what some considerations could be. What workloads could be optimized or even avoided to be deployed? Like, do you actually need that thing that you're about to create, or can it be merged or integrated with another solution? You know, are we over collecting, like, or over retaining data as an example as well? Like, I think it goes back to my comment about how, like, you've kind of reinforced the best practices in terms of sustainability and FinOps as well.
Yeah.
So.
Yeah, one thing I've been looking into, for example, also is, say, for example, Azure deployments. If you are a platform team and you need to deploy a new version, a lot of the times you make like a change somewhere in a bicep file and then just deploy the whole thing. It will see what is different, what is not, and based on this, do the deployment. But this still uses a lot of energy. So if you can split this up in smaller parts and only run the part which is really needed, this could, for example, also reduce the amount of CPU being used and so on. And this is something a lot of platform engineers and a lot of people working with Azure might recognize. Other things are sync jobs, pooling jobs. If you have a system which has to run when a certain value in a database is being changed, and there's no pushing mechanic from the database, but there's only like a pooling mechanic, and you're checking every minute this compute has to run. Check with the people who are using these systems, check your non-functional requirement. Is it really needed that these changes are being done in 1 or 2 minutes, for example? Or is it also okay if it can take up to an hour? And if it can take up an hour, you can reduce this polling rate from every minute to every hour, or maybe every half hour. But this will reduce significantly these database queries, these checks, this there and back, and so on, spinning up, spinning down these automations. So these kinds of things you can easily look into. And a lot of it is really also about figuring out, am I not over engineering the problem? If they need a backup solution and the backup solution only needs to needs to have like an RTO of a week, so it's no problem if the last week of data was being lost, then I don't need a backup solution which backups every 5 minutes. I can set it up to like a week. So make sure you get these data right and don't over engineer it, because it's very nice to say to corporates, hey, I've made it even better, but you might forget to give the other information next to it.
Yeah, and that's a good call out. Like for me, a lot of my background is technical, but also I went through a service management phase as well, where like ITIL processes and things like that. And I think when you're considering application criticality, like I'm a huge believer in actually architecting the solution for the right business outcomes that you're trying to drive through. And part of that is actually, is this service that you're building or architecting or refactoring, is it actually as business critical as you think it is? And if it is, that's great, because there's trade-offs with that conversation. Obviously higher costs, the sustainability implications, but all systems are not the same. All services that you're offering to customers are not the same. So actually tiering your applications properly helps architect them for the right patterns. And so this just adds another layer to that same conversation. So
indeed.
Very interesting. Thank you for donating your evening and knowledge to us again, Leo, for coming and presenting to us today. So,
Yeah. I hope to be back next year or so. I
yeah,
think it was
yeah,
3 years in a row now. So let's see if we can make it 4 years in a row.
100%. Always good to yeah, have you on and present. It's always interesting conversations. So I think it's yeah, and going back to kind of the current state, and everyone's talking about or generative AI capabilities at the moment, and it is one of the things that I've sort of thought about when I'm starting to build these agentic solutions is, does it actually really need an agent? Does it need that LLM that's memory hungry to actually do the job? And so you end up with a mix of like deterministic, which is similar to your PowerShell workflows and stuff, just doing that work supplemented by the agents, not fully. So I think it's an
Indeed.
interesting view.
Well, for sure, you can make a lot of processes a lot more energy efficient if you stop using it AI and just make it a lot more deterministic with just code. But that's often the case when we started doing automation. One of the rules is always, if you can't make it into a flowchart, you can't make it into an automation, because you need to have the whole schedule. And now it's so easy to just say, well, we don't really need this flowchart. We just give it to an LLM and we give it some instructions. And if it works up at any point, we just give it some more instructions, and eventually it will do its job as good as an employee. But yeah, the sustainability angle, I think, will come back very soon again and become more important again in these cases.
Agree. Yeah. 100% agree, and I do think it's one of the reasons why not all regions will have GPU and LLM capacity. Is for sustainability requirements as well. I half expect that's one of the reasons why we don't have GPUs within New Zealand North, because it's a region entirely air cooled. So adding GPUs to the mix kind of goes against that kind of sustainability requirement, because more work needs to be done to optimize those solutions at a hardware lower level. But we'll end it there. But thank you very much for coming and presenting to us today. If anyone has any questions or any further thoughts, feel free to reach out. I'm sure you'll be able to find Leo. And AutoSysOps is his GitHub handle as well. So definitely check that out and look for those scripts. I know I will be. So thank you again.
Thank you very much.
I clicked the wrong button. Sorry, all. Yep, I was clicking leave instead of end stream. So now I will click the right button, and you should, have a good day.